One of the things we're going to want to be able to do is solve exponential functions if we set them equal to a specific output. So we want to be able to find the input that goes with a specific output. So in this video, we're going to talk about how to do that and how to do it with logs. But to get a general idea, let's say we wanted to solve some exponential equations that look like this. 3 to the 2x plus 5 equals 27. In a perfect world, what we'd like to have happen is to be able to write them with the same base so that we can write the exponents equal to each other. So let's say we wanted to solve 3 to the 2x plus 5 equals 27. What we want to try and do is write 27 as 3 to some power. Since 27 is really just 3 to the third power, we can write 27 as 3 to the third power. So 3 to the 2x plus 5 equals 3 to the third power. Now notice how 2x plus 5 is in the same place as 3. That means we want 2x plus 5 to equal 3. And if we solve this for x, we'd subtract 5. 2x equals negative 2. And divide by 2, x equals negative 1. So that means if we plugged negative 1 in here for x, we should get 27. So let's see. 3 raised to the 2 times negative 1 plus 5 should be 27. 3 times negative 2 plus 5 should be 27. 3 cubed equals 27. For this one, we want 2. For part B, we want 2 to the 3x minus 2 to give us 32. We can rewrite 32 as 2 to the 5th power. In doing so, that means the exponents need to be equal. 3x minus 2 needs to be 5. So 3x adding 2 equals 7. And if we try and divide by 3, even though it won't go in evenly, that's okay. X is just going to need to be 7 over 3. But what do we do in a situation where we can't write the number on the right as the same base? What we're going to do is use some log properties. The first log property is this one. If you do a log of some number to a power of p, you can pull p to the front. So notice here how we're asked to solve for the exact value. So let's try and do that. Let's try and solve 4 times 3 to the x equals 40 for the exact value. The first thing you want to do is get the exponential part by itself. So I'm going to divide each side by 4. So 3 to the x equals 10. And this looks kind of similar to the previous problems. And what we'd like to be able to do is make 10 3 to a power. But since you can't do that, we're going to rely on these log properties up here. So what we're going to do is take the log of each side. Log of 3 to the x equals log 10. That property will allow us to pull x to the front and rewrite this as x times log 3 equals log 10. So we're going to divide each side by log 3. X equals log 10 over log 3. And if you put this number in your calculator, you'll see it's just an irrational number. It's a non-repeating, non-terminating decimal. So if you're asked to find the exact value, you would leave this alone. Let's say we wanted to solve an exponential function using the number e. We had previously developed this property. Natural log e to the k is just k. It undoes itself. So we're going to use that here. But first, we need to get e to a power by itself. So I'm going to divide each side by 80. Even though 80 won't go into 20 evenly, we can write that as a simplified fraction. Let's write it as 1/4. Then we're going to use the property to solve this for the exponent. So natural log e to the 3x plus 4 equals natural log 1/4. On the left side, using this property, the result will just be whatever the exponent is. 3x plus 4 equals natural log 1/4. And now we're going to continue solving for x. So I would subtract 4 from each side. The result would be 3 of x equals natural log 1/4 minus 4. Then we're going to divide everything by 3. So we get x equals natural log 1/4 minus 4 over 3. Again, this is an exact value. That number is a non-repeating, non-terminating decimal. When we go to do problems that are involving specific exponential functions, we'll actually want to know what that decimal is so that gives it some practical meaning. But you'll notice in infinity, some of the questions ask you for the exact value, and this is what they're looking for. They're looking for the answer in terms of the logarithms. Let's look at one, though, where we do want to just solve for x, and we're going to round the answer to 3 decimal places. So let's say we wanted to solve this for x. And ideally, we'd like to rewrite 19 as 5 to a power. But we can't do that. 5 to the first power is 5. 5 squared would be 25. There's no way to rewrite 19 as 5 to a power. So we're going to use the log properties. Let's take the log of each side. Okay, that allows us to bring 3x plus 2 to the front times log 5 using that previous log property. So we're going to try and solve this for x. We're going to undo the multiplication first. (3x plus 2) then equals log 19 over log 5. We would subtract 2 from each side. So that's log 19 over log 5 minus 2. And then we're going to divide everything by 3. So this would be the exact value of x, log 19 over log 5 minus 2 divided by 3. And you'll see in the video below, I show you how to compute this value using your graphing calculator. But this value to 3 decimal places is negative 0.057. So that means this value of x is about negative 0.057.